Good morning, everybody. It is Monday morning, April 27th. So, gosh, miss you guys. Wish we were in class instead of doing it this way, but I guess we'll get through this and then we'll see each other on the other side. So, today we're going to start chapter 7, which is an easy chapter. Polygons, which are these funny shaped figures. Okay, so the term poly means many. Polygon means many sides. Okay, so that's just the definition of a polygon. It just simply means many sides. Okay, so if you take a look at the first figure, that's obviously a triangle. It should be called a trigon. That is not a square. We call it a quadrilateral, pentagon, hexagon. So, and they all have these names. So let's go ahead and start right off with the chart. So I started this chart, and what I'm going to do is put over here the number of sides. Number of sides. And then everything has a name. And then the last thing we do is put the sum of the angles. So, for instance, triangle, if we add all three angles, it's going to add up to 180. No matter how you draw a triangle, you know, it's still going to always add up to 180 degrees. So this is going to be the sum of all interior angles. All right? So let's start off with the most basic, which is 3 sides. Number of sides is 3 sides. Name is a triangle, we know that. And if I were to add all the angles up, I mean if I go this angle plus this angle plus this angle, they add up to 180 degrees for a triangle. We know that. Hopefully you guys know that. If you didn't know that, well, surprise. And then you go to the next figure, which is a 4-sided figure. Don't call it a square. It's not a square. It's called a quadrilateral, so 4-sided figure. It's called a quadrilateral. And so what happens is really it's made up of 2 triangles. So 180 is 360 degrees. All right, this is a diagonal, by the way. And the next figure has 5 sides. Hopefully you know this. You guys should have learned this in middle school. If you didn't, don't tell me. Can't tell me anyway, can you? And it's called a pentagon. And a pentagon has 1, 2, 3 sides to it, right? And so then 3 triangles in it. So if you add them all up, you get 540 degrees. This figure, 6 sides, is a hexagon. And a hexagon has, in a sense, 1, 2, 3, 4 triangles in it. So it's just adding another 180. So a hexagon is going to be, let's see, 180 plus that, 720 degrees, right? Now, this gets a little tedious, so there is a formula. So let's go ahead and I'm not going to put them all down. I'll let you guys figure this out, but there's a formula. So if I go 7, the name of a 7-sided figure is a septagon, or a, yeah, let's just go septagon. Septagon, 7 sides. Now, I can keep drawing them, keep making them, but there's a formula. So if you want to find, so the formula is 180, because that's the triangles, times n minus 2, okay? So if you want to find out with a septagon, you put in 7, okay? So you put 7 in here, and you'd go really 180 times, put 7 sides, 7 minus 2, which is 5, and I believe you get 900 degrees for the septagon, okay? 900 degrees if you were to add them all, and I'm not going to try and draw a septagon because I can't. 8 sides, you guys know that's an octagon. Okay, and again, if you want to find out the sum of the angles, you either add 180, which is 1080, or you can just use your formula. 180 times n minus 2, or 8 minus 2 will give you the sum of all the sides. 9 is a nonagon. A nonagon. 9 sides, nonagon. And again, if you want to find the sum of all the interior angles, you just go 180 times 9 minus 2. Oh gosh, can't remember what that is, but you guys can use a calculator to get that. And then 10-sided figure is called a decagon. Again, decagon, if you want to find the sum of all the angles, it's 180 times 10 minus 2, and whatever that is. Let you use a calculator. 11-sided figure is called an undegon. Oh, hold on, you guys can't see this. Shoot, let me get my paper out of here. There we go. Sorry, you guys. There you go. Now you can see it. I think Haley told me this one time, Mr. Davies. No, it's Hannah. Mr. Davies, make sure we can see what's going on. 11-sided figure is called an undegon. And again, if you want to find out how many angles, the sum of the angles, like if you add them all up, if you had 11 sides, add them all up, it would just simply be 180 times 11 minus 2, and you guys can figure that out. Okay, that's part of the assignment. 12-sided figure is called a dodecagon. Now you need to know these names because you'll see them in your homework and also in your quizzes and tests, and then I won't tell you what they are. I won't be there to tell you, so you have to look them up. Okay, but you have notes. So again, if you want to know the sum of a dodecagon, there's going to be 12 angles. It's just simply going to be 180 times 12 minus 2. Well, that's easy. That's going to be 1800, right? So the angles keep getting bigger and bigger and bigger because you have more and more sides and more angles. And then what happens at this point is we stop giving them names, because at what point in time does it become ridiculous? So a 13-sided figure is called a, you ready? It's called a 13gon. And a 14-sided figure is called a 14gon. 14 sides, and then 15, 16, so forth. And if you want to find the sum of their angles, it's just going to be 180 times 13 minus 2, whatever that is. Use your calculator. Okay. Now, no problem. Let's take a look at our journal. So you take a look at your journal, and in your journal on page, I'm going to go to page 225. They talk about some other terms that are important for us. Okay. So first of all, diagonal. So diagonal is just going to be a line segment in a polygon. That's all it is a line. It is a line segment crossing inside. Okay, so a line segment inside polygon. And it does go from vertex to vertex. Okay, so if I take a look here, these are diagonals. That's diagonal. Those are diagonals. Those are diagonals. This could even be a diagonal, right? This could even be a diagonal. So the diagonals are line segments inside the polygon, okay? Equilateral polygon and equal angular polygon tend to be the same thing. Well, equilateral is like all, so lateral, all sides are equal in length, okay? Like a square or a rhombus, okay? Equilateral triangle. And there's an equal angular, see the angle part? All angles are congruent or equal. Okay, like an equilateral triangle, or like a square, a regular pentagon. So a regular polygon is where you get both of these. Happens the same thing. Okay, so in a regular polygon, we're going to have all angles and sides are equal. Okay. So here's our formula. Okay. This is not regular, okay? This is not regular at all. This is irregular. It is convex, which means all the angles are, nothing's pushed in. I'll show you concave. Concave is a weird looking shape. It goes like this. You got a little cave in here. That's concave. Concave, it's been caved in, right? Concave. So you got 1, 2, 3, 4, 5, 6. That's a hexagon. It is a hexagon, but it's a concave hexagon. And this is a convex hexagon because all the angles are popped out. There's no dents in it. That's concave and it got caved in, okay? Now, here's our formula, okay? If you want the sum of the measures of the interior angles, you just go 180 times n minus 2. They just write it backwards. I like it the other way around. Now, but if it's regular, you can find more than that. So, for example, let me just take a nice, and again, I'm not an artist. Let's see if I can do this. I don't have my templates with me, doggone it. But let's just assume, use your imagination, that Mr. Davies drew this beautifully. And that is regular. Let's just use your imagination. This is regular, okay? It means this side is equal to this side, which is equal to this side, which is equal to this side, which is equal to this side, okay? And because it's regular, we can also say that this angle is equal to this angle, which is equal to this angle, which is equal to this angle, which is equal to this angle, okay? So far, so good, right? Now, if that's the case, then not only can we find the sum of all the angles, sum of all interior angles, which would be, well, let's see, let's use our formula. 180 times 5 minus 2, which we got to be 720 degrees, right? Add them up. Just, you know, use your calculator, and you get 720 degrees. So then, what if we want an individual? Only on regular can you get an individual, because these angles have to be equal. Individual interior angle. So, I mean, these are all going to be the same. If I take a look at this picture, they're all going to be different. We couldn't find out what they are individually, but we do know they all add up to, what's that, 700? No. Am I off? This is 540. 540. I need a calculator. 540. My bad. This is 720. 540, right? So then if you want an individual angle, you would just divide it by 1, 2, 3, 4, 5. And I think you get 108. Golly, I should have had my calculator with me. So each of these angles will be 108, 108, 108, 108, 108. Okay? Alright, so that's how you find an individual interior angle. Now, let's flip the page of your journal. Now, they talk about exterior angles, okay? So, exterior, this is an exterior angle. So, exterior angles, if you draw your figure, you'd have, you keep going, that's an exterior angle, that's an exterior angle, exterior angle, exterior angle, exterior, okay? Now, don't put the exterior angles on the other side, okay? So you have 1, 2, 3, 4, 5 exterior angles because this thing is a pentagon, right? And if we wanted to add all these up, angle 1 plus angle 2, angle 3 plus angle 4 plus angle 5, it always adds up to 360. There's never a formula. It is just 360. No formula. The answer, if you want the answer of angle 1 plus 2 plus 3 plus 4 plus 5, it's just equal to 360 degrees. Okay? It's true of all polygons. Okay? Flip the page back real quick. So if I wanted to look at this one here, and I drew all the exterior angles in here, here, these are my exterior angles. Okay, these are my exterior angles, right? And then angle 1 plus 2 plus 3, all these exterior angles, it doesn't matter. It's always going to be 360 degrees. It doesn't matter what the figure is. If you add them all up, it's 360. However, if it's regular, right? And again, I'm not going to draw it very well. Let's see, how about a hexagon? Let's see how good I can draw my hexagon, okay? Again. Okay. Let's just assume this is regular, like this side's equal to this side, equal, 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 right? Then what I could do is I know there's 1, 2, 3, 4, 5, 6, and if it's regular, then all of these are equal, right? So that means it's regular. Excuse me, I'll get my hand out of the way. Doggone it. Come on now. It's regular. That means that, you know, this angle is equal to this angle, which 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 is equal to this angle. So you could find out what those individual angles are, because we know they all add up to 360. It has to be 360, always will. And divide by 1, 2, 3, 4, 5, 6 angles, and you get 60 degrees per angle. Okay. Now, what's your homework going to look like? A little bit like this. So I've got a worksheet I want to look at real quick. And your homework's going to look a little bit like this. So let's take a look at example 5 here. It says, if the sum of all interior angles of a polygon add up to 2,880, how many sides does this polygon have? So it's some polygon. I don't know what it is. I mean, is it a hexagon? I don't know. Is it a pentagon? I don't know. It's something. So we do have a hint. Sum of all interior angles, okay? And we got a formula for that. 180 times n minus 2. We got a formula, okay? Sum of all interior angles. That's our formula. And that answer is going to be 2,000 880. So to find the number of sides, let's just do some math. Okay, so we'll go 180 times n minus 2 is equal to 2,880. Okay, and let's just solve. Darn, I need a calculator, you guys. Here I am without a calculator trying to do this. So we're going to solve. Divide by 180, divide by 180, and I got n minus 2 equals, let's see, I don't know what that is, 18. I can't believe I'm doing this longhand. I need a calculator. Into 288. Is it going once? 18. Right. Cancel, cancel. I get 1, 0, 8. Bring down the 8. 18, and there goes maybe, I don't know. I'll try 5 times. 18 times 5, 40. 5 is 90. Let's try 6, 48. 4, 6. Oh, it is 8. Okay, so it's 6. Okay, 16. There it is. 16. And then I add 2, and n equals 18. So if I had an 18 agon, call it an 18 agon, 18 agon, an 18 agon, if I drew it with all its sides and all of its angles, it would have a sum of the angles of 2,880. Okay, example 6. If I wanted to find the value of x, let's see, I have 1, 2, 3, 4, 5. Is that right? Let's do it again. 1, 2, 3, 4, 5 sides. So I know it's a pentagon. Has 5 sides. I know the sum of a pentagon is going to be 540, and you can check that by using our formula, right? You want to check it, you can go, okay, 180 times, let's see, 5 sides, 5 minus 2, because that's our formula, and I think you get 540. Okay, so all of these add up to 540. So I'm going to go, okay, let's go start here, and we'll go 180, whoops, 108 plus 80 plus x plus 90 plus another x. All that adds to add up to my 540, and darn it, I should have brought my calculator out here, but you guys can solve for that. Let's see. You have a 2x for sure, and 770 plus, what's 170 plus that? Be 278 plus 278 equals 540, and I'll let you solve for x because I don't have a calculator. Forgive me. Alright, and then last but not least, I've got a, again, I think this pentagon, 1, 2, 3, 4. No, this is a quadrilateral. 1, 2, 3, 4. I've got quadrilateral. It doesn't matter. They all have to add up to 360 regardless. So I'm going to go 100 plus x plus 154 plus a 4x equals my 360, because it always adds up to 360, always exterior angles. So I would solve for there. I'd have a 254 plus a 5x equals 360, and I do not have my calculator here, doggone it. I'll let you figure out the value of x. Okay, that's all I have. Homework today, though. I do have that. Keep working, you guys. Before I give the homework, I want to talk real quickly, very, very briefly, about incompletes. Most of you are doing a great job, and this shouldn't be too hard of a way to do this, but incompletes. So at the end of the year, I have to decide whether or not you deserve credit. And if you've been working, yeah, of course you deserve credit. And move on to the next math class, okay? You are scheduling right now, so be careful. If math is really hard for you and you're not doing math, don't take Algebra 2. Take Personal Finance. It's fine, okay? The only reason you need Algebra 2, is if you're going to go straight to a 4-year college. If you're not going to go straight to a 4-year college, don't take it, okay? If you're good in math and you're doing great and you're going to go to a 4-year college, take Algebra 2. Okay, homework today. Let's get that down there. I believe homework today is on page 227. It's right there, 227. Let's take a look at it. 227. I want to see work. Okay, no work, no credit. 227. Okay, let me get it up. 227. Here we go. So 227. Here it is. Page homework. Page 227, 1 through 10, all, okay? Keep up the good work, okay? No incompletes. That would be really bummer, okay?